Okay, this is lesson 24, complete the square. We've been looking at solving quadratics. So we've been talking about how we solve equations where it's going to be a squared variable term. So there's going to be two answers. And we talked about x box and taking a square root. Now we're going to talk about complete the square. This is kind of a hard topic for most students. You should have looked at this in Algebra 1 already. So you should already know how to do this, but I'm going to spend today reviewing it and reteaching it in case you missed it. Okay? Or don't remember it. And this is where the quadratic formula comes from, is from this process. Okay, remember the quadratic formula? Yeah? X is equal to negative b plus or minus the square root of b squared minus 4ac all over. Okay? No one ever heard that song before? That's good. Okay, cool. First period, that was bomb. We all started singing together as a huge choir. Yeah, anyways, Mrs. Cossey should have been here. Alright, anyway, students will solve quadratics by completing the square, and when we complete the square, this is how we get the quadratic formula, so that's where it's derived, so you're going to have to learn how to do that also. You're going to have to learn how to prove the quadratic formula, so you have to know how to do this process pretty solidly to get the answer for them when we deal with that, okay? Anyways, here are the steps. We have them written down in class, but if you're on the video, please pause the video now. I'm going to move on. Okay, here we go. Numbers 1 and 2, just watch right now, okay? Okay, number 1, it says solve each equation by completing the square. On number 1, we could use x box to solve number 1, okay? We could. But sometimes you can't. But I'm going to use this example. You could use x box, a nice easy problem, just so you could see how it all works out, okay? But we're going to use the method to complete the square. So the first thing I'm going to do is, since it asked me to complete the square on my directions, I'm going to take any constants and move them to the opposite side of the equation. So I'm going to move positive 24 to the opposite side. Okay, when I do that, we're going to do the opposite, which is subtract 24 on both sides. So you got x squared minus 14x, and I'm going to leave a little space right next to the 14x, and then put the equal sign here. You'll see why in a moment, minus 24. Okay. So, on this left side now, I'm going to want to make this left side a perfect square trinomial, and the way we do that is we do this thing called complete the square. Take the b term, which is negative 14, and we're going to take half of negative 14. Half of negative 14 is negative 7. Negative 7 squared is positive 49. So I'm going to add 49 here, and also on the opposite side. Okay. And when I do this left side here, x squared minus 14x plus 49 is now a perfect square. Okay. So, which means I could factor it or just use that, factoring technique I taught you a couple weeks ago, where we just know it's a perfect square. Just put x minus 7 squared. And then you simplify the right side. Negative 24 plus 49 is positive 25. Okay, so we just completed the square. Okay, so that last step, by adding 49, that's where completing the square comes from. That's where the word comes from. That's where specifically the term came from. So x squared minus 14x plus 49 is equal to negative 24. This side is a perfect square trinomial. I factored it to be x minus 7 squared. Now, since this squared term on the left-hand side right here is isolated, I could take the square root of both sides, like I taught you yesterday. Take the square root of both sides. Square root, cancel out with square, leaving just x minus 7. And then square root of 25 is going to be positive and negative 5. Okay? We're still solving for x. We're trying to isolate the x variable. So we're going to add 7 to both sides. So we got x is equal to 7 plus or minus 5. And now I could simplify. 7 plus 5 is 12. 7 minus 5 is 2. These are my two answers, okay? Alright? That's number 1. Watch again. First thing I'm doing is I'm going to move the constant term to the opposite side, so I'm subtracting 24, rewriting my equation again with leaving a little space for c, okay, and then writing the negative 24 on the opposite side. Now I'm going to complete the square. Half of negative 14 is negative 7. Negative 7 squared is positive 49. So I'm going to add 49 to both sides. When I do that, the left side now is a perfect square trinomial. I could factor the left side on this next step. And all I do when I factor it is I just take square root of x, which is x, and half of negative 14 is negative 7. Okay? And that's squared, and then I simplify. Since this left side's already a perfect square, we're going to take a square root of both sides. When we do that, those cancel out. So x minus 7 is going to equal to positive and negative 5. Add 7 to both sides. We get x is equal to 7 plus and minus 5. So 7 plus 5 I can still simplify as 12, and 7 minus 5 is 2. And that's my answer. Does that make sense so far? Okay, number 2, watch one more time. Number 2 is a little bit harder. Number 2, so again, we want to move all the constants to the right-hand side of the equation. So we got negative 57 and negative 7. They're separated, but I want them all together on the right-hand side. So I want to move negative 57 over to this side. So the opposite or inverse of negative 57 is add 57. So I'm adding 57 to both sides. When I do that, I get n squared plus 10n is equal to positive 50. Okay? I left a little space here to complete the square, so I'm looking at the b term here. Okay? B term is positive 10. Half of positive 10 is 5. All eyes up here. Don't forget to look. Half of 5 is, or half of 10 is 5. 5 squared is 25. So I can add 25 to both sides. Okay, so we got n plus 5. Or this left side is a perfect square trinomial, so I know half of n squared is n. Half of positive 10 is 5. This is the fastest way to do it, is go n plus 5 squared, because we know it's a perfect square, which is equal to 75. Okay. Since the square term is isolated on the left, I'm going to take the square root of both sides. These cancel out, so we got n plus 5 is equal to positive and negative rad 75. Okay. Then I'm going to take this positive 5, move it to the opposite side, subtract 5 on both sides. We get n is equal to negative 5 plus or minus rad 75. And I'm going to simplify this. Rad 75 is just like saying 25 times 3, right? Would you all agree? Square root of 25 is 5. So I'm going to factor out a 5 or simplify 5 rad 3. I can't bring these two together because this has a radical on it, so it's being multiplied to the 5, so we couldn't just cancel those out. So these are my answers. Negative 5 plus 5 rad 3 and negative 5 minus 5 rad 3. Okay? So it's kind of hard, but this is the easy day, and this is what you should already know. So if you don't know it, then we need to learn it today, okay? We're going to be working on this for a little while. Okay. Any questions on numbers 1 and 2? Yes?
Number 2, the very first step, you did the opposite of negative 57 is plus 57 and plus 57. And then on the second step, instead of doing minus 25 and then minus 25, you just did plus 25. What's that?
Because half of positive 10 is positive 5. Positive 5 squared is
25.
Positive 25. I'm adding 25 to both sides. I inserted that number. I completed the square. I wanted to add that. That just showed up because I forced it to be there. Does that make sense?
Yeah.
Okay. That's a good question. Any other questions? All right, so let's have... Anyways, hopefully I don't do that again. Here we go, number 3. Okay, number 3, let's do this one together, okay? This one you could do Xbox really quickly. You know, you could do this one really quickly. I picked this problem so that we could learn it easily. We're doing complete the square. First step, turn your neighbor, tell them what's the first step. Well, add 7, okay? So adding 7 to both sides. So we're doing this one together, right? Shh. So you got a squared minus 6a is equal to 7, okay? Next step. Okay, half of 6 is negative 3. 3 squared is 9. So we're adding 9 to both sides. Right, we're completing the square. Now on the left-hand side, what do you notice? It's a what kind of square trinomial? Good, so what's the factored form of this perfect square trinomial? A minus 3, okay? And the secret here is you just take the square root of a squared, which is a, and half of negative 6 is negative 3. And then you just square it, okay? That's the secret. 7 plus 9 is 16. Nice, okay? So, take the square root of both sides now. A minus 3. Square root of a minus 3 squared is going to be just a minus 3. Square root of 16 is plus or minus 4. Okay, finish this off, please. The mistakes, most of you got it right. So you would add 3 to both sides, adding 3. So the answer is going to be a is equal to 3 plus or minus 4. What's 3 plus 4? 7. 3 minus 4? Negative 1. Somebody put negative 7, negative 1, or positive 1. I'm not sure where that came from, but those are your two answers, okay? Number 4. Here we go. Number 4, first step. Add 57, right? We don't want anything here, no constants here, so we want to add 57 here. When we do that, we get m squared plus 6m is equal to positive 55, okay? Okay, what is the c term we're going to add to both sides? 9, right? Half of 6 is 3. 3 squared is 9. Adding 9 to both sides. What's 55 plus 9? Good. What's the term on the left, or what's the factored form of the left side now? M plus 3. Good. And that's squared, right? Okay. Why don't you finish off this problem from this point? Go. So after you take the square root of both sides, you're going to get m plus 3 is equal to the positive and negative square root of 64, which is 8. Subtract 3 on both sides. You got m is equal to negative 3 plus or minus 8. Negative 3 plus 8 is positive 5. Negative 3 minus 8 is negative 11. That's your answer. Number 5. This one you can't do x box. Even if you tried, you want to be able to do x box. So you would have to use complete the square. Okay? Looks like you're starting to get it. If you didn't get it, just watch carefully on what I would do. Okay, and that's it. We can't do anything with rad 29, so that's your final answer. Alright, so I'm going to conclude the lesson there because you're all getting it at that point. I don't want to waste any more time. I want you to practice, so that'll conclude our lesson.